Okay, so let's start the next part of the stable diffusion. So the continuous training of the model leads to an upgraded denoiser model that has learned to clean data by mapping noisy data. This refined model can then produce new data by proceeding with a random noise through the denoiser. Although the new data may resemble the original data, it has variations controlled by the level of noise added. Compared to other generative models, stable diffusion is less prone to overfitting the training data. This is because the denoiser model must learn to denoise all noise levels due to range of increasingly noisy data that it is trained on. As a result, the model generalizes well to new data and is less likely to overfit training data. This is why stable diffusion models are called stable. Stable diffusion model benefits for app development. A stable diffusion model offers the following benefits to developers interested in building apps using it. New data generation. With stable diffusion models, you can generate new data similar to the original training data, which proves useful in generating new pictures, text, or sounds. High quality data. Compared to the other generative models, a stable diffusion model is less prone to overfitting because it is trained on increasingly noisy versions of the training data. As such, it can produce high quality results devoid of noise. Ease of use. Stable diffusion models are implemented using deep learning frameworks like TensorFlow or PyTorch. The high-level APIs this framework offer to build and train neural network makes suitable diffusion model relatively simple to implement and experiment with. Robustness. A stable diffusion model is immune to changes in data distribution over time because it is not sensitive to variations in data distribution. As a result, it is well suited for building applications that handle data availability. Transfer learning. To adapt stable diffusion models to a specific task, they can be fine-tuned on a smaller data set. This is known as transfer learning, which can diminish the computation and data required to train a high-quality model for a particularly use case. Applications. The potential applications of the stable diffusion model include the following. Image and video processing. Stable diffusion models can be applied to image and video processing tasks such as denoising, in-painting, super resolution. Clean and high resolution images can be produced by training the model on noisy images. Data generation and augmentation. The stable diffusion model can generate new data samples similar to the training data and thus can be leveraged for data augmentation. In industries like healthcare, where collecting annotated data is challenging and costly, it can be handy for medical imaging. Anomaly detection. In the industries of finance or cybersecurity, stable diffusion models can be used to detect anomalies or unusual patterns in large data sets like network logs or security events, helping prevent fraud and promoting network security and quality control. Data compression and dimensionality reduction. To reduce the size of large data sets, stable diffusion models can be used to compress a data set into a lower dimensional representation. This may prove useful in industries like finance and telecommunication, where storing large data set is challenging. Time series analysis. It is possible to forecast future values and predict future trends using the stable diffusion model with time series data such as stock prices, weather patterns, and energy consumption. Recommender system. Various domains such as e-commerce, music, and movies can use the model to build recommender system. The user's past interaction with a product or service can be used to train the models to make personalized recommendations based on user behavior and preferences. Platforms and frameworks to develop a stable diffusion model powered app. App development with a stable diffusion model requires developers to choose from numerous robust platforms and frameworks designed for AI-based apps. There are many options available, but these are most popular and widely used. TensorFlow, as a powerful and flexible open source platform to build and deploy ML models, TensorFlow offers comprehensive and user-friendly framework for training the stable diffusion model. There are various types of neural networks supported by the platform, including convolutionary neural network, recurrent neural network, and deep neural network. TensorFlow also provides numerous tools and libraries for pre-processing, transforming, and managing large datasets, essential for training AI models. Keras, an open source software library called Keras, offers ANNs, a Python interface. It operates on top of Theano, CNTK, or TensorFlow. Keras was created to facilitate quick experimentation and can function on both CPU and GPU. As a high-level API, Keras makes it simple to create, train, and assess deep learning models. It offers a simple, user-friendly interface for specifying stable diffusion model architecture and training them on huge data sets. PyTorch. PyTorch is another popular open source platform used to create deep learning models. It offers a complete collection of data tools and libraries for developing, training, and deploying many machine learning models, including stable diffusion. Developers find PyTorch's user-friendly and intuitive interface helpful in building and experimenting with different models. Django is a high-level Python framework that facilitates developers to create robust and secure web applications swiftly, as it provides a set of libraries and tools to manage web development tasks. It can be leveraged to build the backend of a stable diffusion model-powered application. It is a modular framework enabling developers to add or modify new features, which makes it an apt platform for building complex applications. Streamlit enables the development of modern, highly responsive, interactive machine learning application. It allows users to create and deploy AI models, including stable diffusion models, without complex coding or web development skills. It is an ideal for building fast and responsive data-driven application because it provides a simple, intuitive, highly customizable interface. Owing to its ease of use and capacity to handle large data sets and models, it is a popular platform for building AI applications. Summary. The Stable Diffusion model is a robust tool for building AI-based applications and offers numerous benefits over conventional applications. Building an app using Stable Diffusion involves elaborate and sophisticated steps like gathering data, training the model, incorporating it into the apps, and launching and continuously monitoring it. It is a difficult process that requires a solid grasp of the Stable Diffusion model and proficiency in coding language like Python. However, with the right resources and skills, a powerful feature-packed and highly performant app can be built using the Stable Diffusion model. Thank you.